Okay, so this is an application of discrete probability distributions. And a discrete probability distribution is one where the values of the variable are discrete. And that would be like cans of cola sold at a gas station, right? You can sell 10 cans of cola, you can sell 9 cans of cola, but you can't sell 9.5, right? So that makes it discrete. Now, what else does a gas station sell? Well, it sells gasoline. Well, gasoline volume is a continuous random variable because you can sell 10 gallons of gas, you can sell 9 gallons of gas, but you can also sell 9.5 gallons of gas. You can sell 9 and 1/10 gallon of gas. You can sell 9 and 100 gallon of gas, and you can continue doing that. There's no smallest unit. So that distinguishes continuous from discrete. And this is discrete because the owner of a refurbished laptop store reviewed sales records, determined the number of warranty repairs, right? She'll be called on to perform during the year following the purchase date. So number of warranties, she could warranty 10, or she could warranty 9 or not, but she can't warranty 9.5. So that makes it discrete, right? So one is identifying that it is discrete, right? We're told that it's discrete up here, but we have to verify that, right? And so number of warranty repairs, that number is discrete, right? And her records indicate the probability of a randomly selected refurbished laptop needing a warranty repair during the year following the purchase date is this, right? So how did she come up with this value? Anybody know? Do you know how she would come up with this probability value?
Repeat that one more time, please.
How would a repair shop come up with this 0.075 in my problem? How would they come up with that? They're using historical records, right? Well, maybe.
Looks like it.
Yeah, maybe 75 out of 1,000. Maybe she sold 1,000 laptops, right, that she refurbished. And 75 of the 1,000 she refurbished did what? Needed a repair, right? A warranty repair, right? So she gets this value from historical records, right? Y'all see that? If she's sold 1,000 and 75 of the 1,000 needed a repair, then she's probably, if nothing's changed in her store, if the quality stayed the same, then she's probably safe in assuming that in the coming year, 0.075 of the laptops that she refurbishes and sells will need a warranty repair, right? Okay. So that's where that number comes from. Now, the owner assumes that calls for warranty repair are independent of one another. And that would make sense, right? When somebody goes into a repair shop, right, and you buy a laptop, does that purchase at all have anything to do with a purchase from a different customer a week later? Now, if I purchased a laptop from this owner and my wife goes in the next day and purchases a laptop from the store, and we have triplets, and the triplets like to rip keys off the keyboard, right? Is that warranty repair independent? Probably not, right? Those two warranty repairs wouldn't be independent. But I suspect that this person's probably buying and selling to people, maybe just out of college, maybe in college, and a refurbished laptop is cheaper than a brand new laptop. So we're probably safe in assuming that a person purchasing a laptop today is independent from a person purchasing a laptop the next day, right? If they're in the same household, that may not be the case, because maybe they have really rambunctious triplets, like my wife and I have, right? But for the most part, I think it's probably okay to assume independent, right? And she probably has records like addresses, right, of the customers, so she's not seeing a lot of spouses buying laptops from her, right? Husbands and wives buying laptops from her, right? Okay, so what else do we need to know? Okay, and the next thing is, in mine, she calls a lot 23, right? So that's the sample size, right? This right here is a probability of needing a warranty. And this is the sample size, N, right? My sample size is 23, right? Maybe she buys laptops, right? And then she hires people to fix the laptops and refurbish them, right? Techs and IT people. And they give them back to her in lots 23, because that's what I have, right? So maybe she gets them in lots of 23. Now, the average warranty repair takes an hour to fix at a cost of $50, $55.74 in my problem, right? So this is the cost. I'm going to put it over here because it's not a part of this experiment yet. This is the cost of warranty. I'm going to call it W. The cost of a warranty on average, right? Because it takes an hour to fix, and maybe she has to pay somebody $55.74 an hour to fix it, right? I'll turn that into dollars. Okay. Now, she's trying to predict the number of warranties that she'll have for the 23 laptops she just purchased, right? Your lot is going to be a different size, right? Mine's 23. Okay, so what kind of distribution is this? What kind of discrete distribution is this? Does anybody have any idea? Here's a clue, right? When she's calculating the probability, what are the outcomes of these 23 refurbished laptops? What are the outcomes of it? Right, she has these 23 refurbished laptops. The laptop can be what? Warranted in a year, or
I was going to say either a success or a failure, obviously.
exactly. And success here, when she's calculating the probability of a warranty repair, right? Now, warranty repair is not a success for her, right? The more warranty repair she does, the less successful her company is. When we're talking about this kind of experiment, success doesn't have to be a positive, it doesn't have to have a positive meaning to it, right? Success is just a yes, right? Yes, something happened. What's the opposite of that? No, that something didn't happen, right? So when you're talking about binomial experiments, there are two events, success or failure. And the successful event is the thing that you want to calculate a probability for, right? And here, what she's trying to calculate is a warranty repair, right? So she's going to either have to warranty it or not, right? So in a sample of 23, could none of them need a warranty? Is it possible for her to have 0 warranty repairs? Is that possible? Anybody?
Read that one more time.
Is it possible that none of the 23 in my problem, none of the 23 laptops will need a warranty repair? Is that possible?
I'm not so sure. Probably not from the sounds of it.
Well, remember that the warranty only applies to the person who purchased the laptop, right? Maybe that person
So that
sells the laptop to somebody else. That voids the warranty. right? If it's a limited warranty, it's limited to the person who purchased the product initially, not the people who, it's not a transferable warranty. So could all 23 buyers of these laptops sell them to somebody in 4 months, and 3 months, and 2 months? Yeah. Right. That's possible, right? Is it
Yeah, now that you
possible?
mention.
Yeah. Is it possible that none of these laptops will need a warranty? Will need a repair because they don't break? Is that possible?
Nope, because things will break.
Yeah, but maybe the 23 laptops are put in a box and not used. Is that, I mean, is it possible that somebody's going to buy this laptop and give it to somebody who is out of the country and won't be back for a year? Is it possible that that happens? Yeah. Is it possible that the 23 people who buy these laptops use them very little? It's possible, maybe not probable, but it is possible, right?
Yeah.
It's
I
possible,
mean, the
right?
only way the,
Yeah.
the only way I can see them being broken is if they were being roughhoused.
Maybe roughhouse, right? Yeah. Or maybe people are downloading free software off the internet, right? And you know it's not free because when you download something for free off the internet, what comes along with that free? That free poker, right?
Contracts.
Yeah. Viruses, all kinds of things, right? So suppose that the 23 people who buy these laptops really don't use them that much that often. They're not using them for vices. They're really just using them to Google something, you know. Maybe it's possible, right? It's possible that 23 people don't have kids, right? And so they're not rough with them, right? So it is possible to have zero warranty, right? That's why I put a zero here, right? It's possible. Maybe not probable, but it is possible, right? Is it possible that one of them is warranted? Yeah, that's possible, right? Is it possible that two of them are warranted? Yeah, right. How about 24 of them? Whoops, I got to 24 first. Is it possible that 24 of these 23 laptops will be warranted? I only have 23, right? I only have 23 in my lot, 23, right? Is it possible that in the lot of 23, that 24 will need a warranty? Is that possible?
Nope.
That is not possible. Why? Because there's only 23, right? So your last outcome, the last outcome of your experiment is the number in your lot, right? I have a lot of 23. My last computer, the last outcome in my experiment is 23, because I only have 23 laptops, right? So not only is this discrete, it's finite, right? If there's no theoretical limit, then it's infinite. But here, this is finite, right? There's only 23. I have a lot of 23 laptops, and out of that lot, only 23 of those 23 laptops will need a warranty repair, right? You can't have 24 in my case, right? Everybody see that? Okay, so this is a binomial experiment. This is the probability of success. This is the size of the sample, right? You know it's binomial if zero is possible, if it's finite, and both of those are true, right? There's independence, right? From laptop to laptop, right? There's a probability of success. In this case, the probability that a warranty repair will be necessary, right? Binomial, bi means two, right? Binomial, the bi part means two, right? There's only two outcomes: warranty, no warranty, right? So all that stuff makes you think about a binomial distribution. Now, in this experiment, the probability of success, this is helping you think about it. Mine is 0.075, right? There is a probability of failure, right? Typically, the probability of failure is denoted as 1 minus p or q. It's either denoted p, the probability of failure is denoted, denoted p or 1 minus p. Q or 1 minus p, right? So this p here is probability of success. This is the complement, right? The complement. The probability of a warranty repair, the probability of not having a warranty repair, right? So 1 minus 0.075. Some textbooks refer to it as Q. Other textbooks refer to it as 1 minus P. The reason why they use Q, because Q looks like a backwards P, right? You see that? This is P, and that's Q, and this is just a backwards P, right? And this is the probability of success, and that's a backwards probability of success, right? This is probability of success, that's probability of failure, right? Okay, so my probability of failure, which is got a good connotation, right? You don't want warranties, right? And then the number of trials for me is this lot of 23, right? She bought a lot of 23. There were, and successes range from 0 to the high of 23. You could have 23 warranted laptops. She could have 0. She could have 1, 2, 3, 4, yada, 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 22. She could have 23, right? And the distribution of the number of warranty repairs in a lot of 23 refurbished laptops is binomial. Okay, that's right there how you think about the problem. You have a probability of success, right? You could have 0 successes or 23 successes. And then on top of that, you have this thing called independence, right? The trials are independent. Now, what does the owner expect? The owner expects how many of the 23 to need a warranty repair? If 50% of students at A&T were female and 50% were male, right? And you randomly sampled class, if the classroom represented a random sample, right? And there's 30 people in your class, how many students in the class do you expect to be male and do you expect to be female? What do you think?
15 and 15.
How did you come up with 15 and 15?
Since it's expected to be 50% male, 50% female, and you're going in a class of 30, 50%.
So you multiplied 0.5, right? You multiplied 0.5 times 30 and got 15, right? 0.5 times 30 is 15, right? 0.5 is a half, right? 0.5 is a half. And so you could multiply a half by 30 to get 15. But 30 times a half is the same thing as 30 divided by 2, which is 15, right? So you take the probability, in that case, 0.5, times the 30, right? How do we get this expectation here? I don't have 50% being bad, right? Need a warranty. What percent is mine needing a warranty? 7.5, right? 7.5%.
Yeah.
So to get the expected value, I'm going to write E as the word expected. The parentheses are the word of. So this is the expected value of what? Of X. X is my random variable. X can be anything from 0, in my case, 23, right? That just means the expected value of this variable that ranges from 0 to 23, right? Well, the way I get that is you just take the probability of success times the size of your sample, right? Instead of 0.5 times 50, I have 0.075 times 23, right? So I expect 1.725. My version of this problem, I expect 1.725. Okay, round probability values to 4 decimals and all other non-integer values to 2. So I need to round this to 1.73. Oh, sorry. 25. I gotta fix that. Hang on a second. Let me pause the video. Okay, so I edited this here. Let me there you go. I said round probability and expected value to 4 decimal places. So that'll fix that right there. So this is 1.725. Okay. Now the probability that none of these 23 laptops, none will require warranty repair during the year following the purchase date equals what? Well, that's this outcome here, right? What is X? X is the number of laptops that need a warranty repair during the year following the purchase date. That blue phrase, warranty repair during the year following the purchase date, that is X, right? Everybody see that? That's X. We're saying X, this is a synonym, X in this problem, X is a synonym for warranty repair during the year following the purchase date. That's like Sasha Fierce and Beyonce refer to the same person, right? Right? Beyonce is still popular, right? My popular music references and movie references have gotten really old. So I just want to make sure I'm still relevant with my references. Beyonce's still big, right? Still a major star, right? Beyonce? Nobody's heard of her? We're good?
I've heard of her, but don't exactly care for her at the same time.
Well, that doesn't matter whether you care for her or not, right? I think she's cool. But Beyonce goes by the stage presence. I guess her stage presence is Sasha Fierce, right? When she goes on stage, she takes on this persona called Sasha Fierce, right? Or P Diddy. P Diddy. I don't know if you guys know who P Diddy is, but P Diddy goes by Diddy, right? Or Sean Puffy Combs. They're all the same person, right? In this problem, warranty repair is the variable X, right? And we want to know whether that blue phrase X is 0, right? None means 0, right? So we're looking for this probability here. So we didn't, man, I cannot say that word today. I got a really bad migraine. We represent the probability with the F parentheses. F is the probability distribution function. Some books use P parentheses X. I generally use F, right? Because I call it a probability density function, right? F for function, right? And our function is what? What was the distribution called again?
What?
What was the name of the distribution?
Binomial.
The binomial. And what do you think we do in Excel? We start typing binomial, right? The first one is the one we want because it says returns the individual term binomial distribution probability, right? Function. So we're going to stop right there and then we're going to hit .get, right? Okay, now what is it asking for? It's asking for the number of successes. Here, I want to know the probability that none of these 23 laptops require a warranty repair. So X here is equal to what? 0.
0.
So number of successes is 0 here, right? Do I want to type 0?
No, you
What
put
do I-
you do A7.
Yeah, I can just click on it, right? I can click on it. See
Yep.
that? I want that to be free, right? And then I'm going to click on probability or the number of trials, right? What's the number of trials in my problem?
20?
Mine's 23.
Well,
Right.
mine's 20, but regardless, it's 23 in your.
In my problem, it's 23, right? I had a lot of
Yes.
23. Do I want to type 23?
Again, no.
Well, what I can do is I can click on B3, but I'm going to pull this probability distribution down, right? I want the B3 to be frozen, right? How do I freeze the B3?
You put the $sign between the B and the 3.
Yeah, exactly, right? Does everybody understand that? You put a $sign between the B and the 3, and that freezes this box in row 3. Everybody see it? Questions on that? I can freeze B3. I want to freeze B3. I don't want that. As I pull this down, as I copy this formula to the cells below, I want the blue box to move, but I want the red box to stay put, right? Whoops. I forgot I highlighted it. So I'm going to put a $sign in between the B and the 3. Freeze row 3. I'm going to do a comma. Now I want the probability of success, right? What's the probability of success here?
In your case, it's that 0.075.
Exactly. It's the 0.075. And again, I want to freeze the purple box in row 1, right? I want to freeze it in row 1. I'll put a $sign between the B and the 1. And the last thing I have to do is what? I want probability mass function, or do I want the cumulative? I want the probability mass distribution. So I'm going to do false. In other words, I just want the probability. I want the probability that X equals 0, not the probability that X is less than or equal to 0, right? If I want the probability that X equals 0, I want to type false. If I want the probability that X is less than or equal to 0, I type true, right? And I get, you want to make this 4 decimals, right? So that's the probability there, right? That's the probability. I'm gonna pop it right into there. And get a green check mark. Okay. Now watch as I pull this down. What happens? As I pull this down, what happened here? The blue box came down. Why'd the blue box come down? There's no $sign there, right? Why was the red box and the purple box frozen? Because there's a $sign freezing these rows, 3 and 1, right? Is another way to do this. Yeah, I can name this box B1. I can name that P, right? Now this is B1. It's B1 or P, right? B1 or P. I can name this, instead of B3, I can name it N, right? Now this is B3 or N. Yeah, B3 or N. Then I can come down here. I can call this B3. Well, I named that N, right? I named that N. Notice in my list here, I got capital N and A all the way down to not. But then I got, these are all functions, right? This little n is a collection of cells, or a cell, right? And then I can name this P, right? I can name that P. And notice the P with a collection of cells, right? And then this is N, and that's P. So that might be a more intuitive way to do it, right? Might be a more intuitive way to do it. And then I can just double click that bottom right-hand corner, right? Notice the probabilities down here are all 0. Are these 0 probabilities, by the way? Are those 0 probabilities? All of them? No. To 4 decimals, yes. But they're not 0. See that? They're not 0. Right? They're not 0 probabilities. But they're really, really close to 0, right? They're very improbable values, right? Not 0, but they're very improbable. I'm going to go back in time by doing Control V. So observations 9 through 23 are very improbable. Which was the most probable outcome? Which was the most probable?
The first one,
Yeah.
which would be
One,
0.3104 for you.
yeah, one of the 23 laptops needing a warranty repair is the most probable. Why? And the second most probable is 2. Why is that? Well, that's where expected value is, right? Our expected value is between these two. You see that? So those are going to be our most probable and second most probable values. They're right around the mean, right? All right. The probability that one of these laptops will require a warranty repair during the year following the purchase equals what? Well, this is 1, right? Again, this right here, that's x, and x equal 1, right? We want to know the probability that x equals 1. In my case, 0.3104. Probably that 2 of these, so this is the value of x, right? And again, x is a warranty repair during the year following the purchase date. That's x, and this is x equal 2, right? Notice this is a probability distribution because each of these probabilities is between 0 and 1, right? Between 0 and 1. And what do they sum up to? What do these probabilities sum up to? What do they got to sum up to? Be a probability distribution. They got to sum up to 1, right? So each of these probabilities is between 0 and 1. There's nothing negative. There's nothing bigger than 1. And they sum to 1, right? Everybody got it? All right, moving on. The probability that at most, what does at most mean? Is at most less than 2? Less than or equal to? Is it?
It has to be less than or equal to. Has to be
Yeah.
less than or equal to.
Yeah, it's not greater than 2, right? It's not greater than or equal to 2. It's not less than 2. It's 2 or less, right? Probably of 2 or less. I'm going to write this as x less than 3, right? Which is equal to the probability of x equal 0 or 1 or 2, right? Or it can be written like this. Give me a second. I'm going to underline the less than symbol. I can't underline the, yeah. There you go. See that? So I'm looking for the probability less than 3, which equals the probability of x equals 0 or 1 or 2. And that equals probability of x less than, or equal to 2, right? I could also write it as this. I could write it as probability of x equal to 0 plus probability x equal 1 plus the probability x equal to 2. All those three things mean the same thing, right? This, because it's discrete. If this weren't discrete, I couldn't say this, right? If this were continuous, I couldn't say this, but this is discrete because x takes on a value of 0, 1, 2, 3, etc., all the way to 23. It doesn't take on values between 0 and 1, or values between 0, 1 and 2, or values between 2 and 3, right? So the less than or equal to 2 is probably that x is equal to 0, equal to 1, or equal to 2. And when you have the word or, what do? You sum the individual probabilities, right? You sum those individual probabilities. So this right here is equal to the sum of those three, right? We're going to sum those three probabilities. X equals 0, x equal 1, x equal 2. We're going to sum those three. Another way to do this is this way. Binomial dist. Look on this is 2, and then trials n, and then the probability of success. And then I can do what? I can do true here, right? True is the cumulative, right? It just adds up current one, previous ones, right? I can do that too. But I always say there's more than one way to skin a cat, and I don't know where that comes from. I don't know where that idiom comes from. Right? More than one way to state the problem, right? State the thing you need. And here there's more than one way to get that answer, right? Okay. So let's see if we get it right. We got it right, right? All right, the probability of more than 2. What about more than 2? How do we do more than 2? Let's do the probability of
Be
more
greater than 2,
yeah,
which
so
means
greater
that'll
than,
have to equal 3.
yeah. So greater than 2, right? Greater than 2 is, what's greater than 2? Is 2 greater than 2? Whoops, this should have been 2 out here. Right. All right, that should have been 2. Is 2 greater than 2? 0 greater than 2? No. Right? Is 1 greater than 2? No. Is 2
Nope.
greater than 2?
Nope.
Nope. 3 is though, right?
Yep.
3 is greater than 2. 4 is greater than 2. 5 is greater than 2. Right? We can keep going, right? Yada, yada, yada. What?
Basically, it goes all the way down to the n, which would be 23 in your case.
Yep, exactly. And 20 in your case, right? Correct? 20 in your case?
It is.
Yeah, 23 in my case, 20 in Craig's case, right? That's one way to do it, right? So let's do that down here. I'm going to move this down here. I'm going to grab this box. I'm going to go the probability of, I want to sum the probability of 3, probability of 6, the probability of 5, all the way down to the probability of 23, right? You see that? And I get 0.2463. Now, what do you think these two add up to? What do those two add up to? They add up to 1, right? They add up to 1 because this right here, x greater than 2, what's the complement of x greater than 2? What's the complement of X greater than 2?
Less than 2.
Well, less than or equal to 2, right?
Yeah.
Yeah, less than or equal to 2, right? That's the complement, so we use the complement rule, right? We use the complement rule, right? We can use the complement rule. Let's use the complement rule. We wanted a sum, right? This is the probability that X is less than or equal to 2, right? Because it includes 2, it includes 1, it includes 0, right? That's the complement we already entered, right? All we gotta do is we gotta do 1 minus it, right? 1 minus it. We're doing 1 minus the sum of the probabilities of X equals 0, X equal 1, and X equal 2. So there's, again, a couple ways to find the answer, right? A few ways to represent the question. Oops. See, 2 laptops under warranty cost the owner what? What does it cost to fix 2 laptops? What is the, if you have to fix 2 laptops, how much is that going to cost you?
Isn't that gonna cost you that 50 some dollars or something?
Yeah, so seeing no laptops, if you, if at the end of the year, you look at your records on these 23 laptops, right? Because you have their ISBN numbers, whatever. You have your numbers, right? You have maybe put a stamp on the back of it, right? You got this brand. You heated up some metal and you put a stamp on the back of it, right? To make sure that people are being honest, because people can bring in a laptop with the guts changed, right? So maybe you have wax over the screws and you put a brand on it. A brand is, a brand stamp is you could put a number on it and you could burn the number into the bottom of the plastic, right? So you have these 23 laptops that you sold, and maybe you know that none of them were warranted, right? What would that cost you? It would cost you 0, right? 0 at a cost of $55.74, right? I'm going to put a dollar sign between the E and the 1. So I put my cost warranty in the cell E1, right? So if none of those laptops come back, it cost me $0, right? I'll change it to currency. Okay, now what about if one of them comes back? Well, it cost me $55, right? $55.74. If 2 of them come back for warranty work, that'll, whoops. Control Z is awesome. I'm going to grab the bottom right-hand corner. If two of them come back, I'm multiplying by 2, right? You see that? Multiplying by 2. If 3 of them come back, I'm multiplying that cost by 3. Everybody see that? If all 23 come back, I'm multiplying the cost by 33, right? Or 23, sorry.
What was that formula? I need to see that form.
Yeah, I'll go back up and do it. I'm just multiplying the value of X right here. By the cost of an individual laptop, right? This is the average cost per laptop. All right, so this is a per laptop cost right here, right? E1. And I put a dollar sign between the E and the 1, right?
All right.
Okay. So the cost of 2 laptops under warranty, right? Seeing 2 laptops under warranty costing the owner in my case, that amount right there, right? Almost $112. And I don't want the dollar sign. I want the dollar sign. I don't want the dollar sign because I already have dollars there, right? Now, how do you get the expected cost? There's two ways to get the expected cost of fixing the 23 laptops, right? I can calculate the expected cost here, right? Whoops. If I want the expected cost, I multiply this outcome by the probability, right? You see that? I want to find the expected cost, right? So I'm multiplying the outcome. I've changed the outcome from X to cost, right? Originally, my outcome was X, 0 laptops fixed. 1 laptop fixed under warranty, 2 laptops fixed under warranty. I'm changing the outcome from X to cost, right? Then I can just double click and get all these costs here. I'm going to also reduce the number of decimal places. Okay.
Almost.
So I'm just multiplying the probabilities of each of these outcomes, right? I'm just multiplying the probabilities by each of these outcomes, right? You see that? Now I'm going to sum. I'm going to delete that sum. I'm going to sum this. So I summed all those, right? I summed all those. And those are just the cost times the probability, right? The individual cost times the probabilities, right? 96.15 is my expected cost. Now, is there another way to get the expected cost? Is there an easy way to do it? Is there an easier way to do it? Well, how many of these laptops do I expect to repair? I expect to repair 1.725 of them, right? I just multiply that times my average cost of repair. Yep, I get the same thing, don't I? 96.15. So there's a couple ways to get the expected cost. There's also another way to get the expected number of warranties, right? I could do the expected number of warranties, right? If I multiply this, multiply the outcome times probability, I can get the expected number, right? Just sum those. And I get 1.725, right? See that? So I can get the expected number of laptops needing warranty work by multiplying the X times the probability, right? X times the probability all the way down, right? And then I can sum 24 values. So that's my expected number of warranties. And if I change the outcome from X to cost, right? I'm just multiplying the probability times this new outcome. And then I sum that, and I get the same number, same cost as if I just took the cost times the expected number, right? Anybody have any questions on that? So here's the question you want to ask yourself. Why do firms warranty their products? What are the advantages of it and what are the disadvantages of it? Right. I mean, there's reasons why people warranty their products, right? I don't know if you've ever seen the movie Tommy Boy, But Tommy Boy, played by Chris Farley, rest in peace, Chris. Chris plays a son of the guy who owns Callahan Auto Parts, and they make brake pads. And they didn't warranty their brake pads because they made the best brake pads, and their brake pads were going to last forever, right? But some people like the warranty, right? They're not going to buy a product without the warranty. So warranty could be good. I mean, it could trigger a bunch of new sales, but it could also result in high expenses. Like, for example, if you warranty tires to 80,000 miles, but the people that are driving the car, they load the car up with friends and family, and everywhere they go, they have 6 people in the car. Those tires are probably going to be worn out quicker than they would if just one person drove the car. Or maybe use your car to haul, maybe you're a repairman or repair person, and you go buy a bunch of parts, and your car is heavily loaded by metal parts, and you're always driving around the city with these heavy loads. You're going to wear your tires out faster than the average driver, right? So also, some people try to take advantage of warranties. They'll pass off a laptop as if it was the one that they purchased from the company, right? So think
Excuse
about
me, sir. Can you scroll up the open math up? Can you scroll the open math page up?
Yeah.
Thank you.
Yeah. So think about the warranty issue, right? When you go buy a set of tires next time, think about the warranty and all the stipulations that go into the warranty. Like on a set of tires, you have to rotate your tires like every 3,000 miles. They have to be properly inflated. You also have to have alignment. And if you have a bad shock absorber or a bad tie rod or a ball joint, it'll cause abnormal wear on the tire, and it'll void the warranty. So there's also stipulations in the warranties as well, right? Some warranties, if you sell the car, like I had a 1977 Honda Civic, and I couldn't pay for people to fix it. So what I do is I'd get an estimate, and then I'd go buy the part at the AutoZone, then called Shucks Auto Supply. And the part was lifetime warranty, but it had a limitation on it. It was limited to me. As long as I owned the car, they would replace the part. If I sold the car, the warranty's off, right? So I had a car replaced with lifetime warranty parts: the alternator, the brakes, the shocks, the struts. They were all a lifetime warranty, right? The battery is the only thing that didn't have a lifetime warranty. The battery had like a 5-year warranty. But at some point, most of the parts of my car were under a lifetime warranty. And as soon as I sold the car, those warranties were null and void. And do you have any questions on it?
No, sir, but I'm gonna
Yeah.
go ahead and take my leave because I
Okay.
pretty much I did my assignment.
Okay, cool. Awesome. Yeah. Anybody have any other
I'll see you
questions? Yeah, see you next Monday.
Bye.
Bye. Anybody else have any questions before we sign off? I thought we'd be able to get through that quicker, but I'm long-winded.
No.
All right. Well, have a good night.
Professor.
Yeah.
You too.